Welcome to Ask and Learn.
This problem tells us if we have a labeled tree, is a tree where the vertex is assigned a label. So if we have two labeled trees, considering isomorphic, which means we can rearrange just with a little bit of flexibility when there is an isomorphism between them that preserves the labels of the vertices. So how many non-isomorphic trees will there be if we have three labeled vertices with different between 1, 2, and 3, and then also the same thing with 1, 2, 3, 4? So let's go ahead and just take a look at a couple of scenarios. So let's say n equals 2. So we have a possibility of having 1 and 2. Well, we would have one vertice and two vertices. So we would have one way. And if we look at n equals 3, then we have, we're going to have 3 vertices. So let's say we have 1, 2, and 3, where 1 is the root vertex, one where we have 2 as the root vertex, and then we would have 1 as the 3 vertex, which is 3 different ways to share this. So if we are looking at this in terms of 2 to the whatever power or 3 to the whatever power, we're going to have n to the something power. So what is going to give us 2, or what's going to give us 1 for this one? Well, it would have to be n to the 0 power. So we could do 2 minus 2, which would then be n to the n minus 2 power. So let's test this for the second one. So if we do n to the n minus 2, that's going to be n or 3 to the 3 minus 2, which would be 3 to the first, which is 3. So this works for this one. So considering the fact if we have n equals 4, we're going to have 4 to the n minus 2, which is going to be 4 to the 4 minus 2, which is 4 to the 2 power, which is 16. So there would be 16 different ways to represent 1, 2, 3, and 4.